Hi everyone. Uh, Today we'll discuss in this fourth lecture of function, that is the graphs of function and transformation. This topic yields the graphics of different variety of functions and shifting in mean of transformations. In this transformation, we can hold how the graph shifts with respect to axis or axis shifts with respect to these graphs. So let's start. Okay. So first of all, we have to remember the very basic level of graph. So let me zoom. First graph, as we have to go for y equal to x. Mind this point, y equal to x is a straight line which makes angle 45 degree from positive x-axis. Now y equal to minus x. Y equal to minus x is a line making an angle 135 degree from positive x-axis. If you see over here, that is 135 degree angle. 135 degree angle. Here the angle is 45 degree. That is 45 degree. Okay. Now y equal to mod x. What is y equal to mod x? Let me zoom in. For y equal to mod x, this is the graph y equal to mod x. The graph is of V shape, as we have discussed in the earlier lecture in detail about absolute value function in the section of piecewise defined function, which is the extended part of third lecture. So we say mod x is piecewise defined function, as for x is greater than 0, or you say equal to 0 also, you can say for x is greater or equal to 0, that is the line y equal to x, and for x less than 0, the line is y equal to minus x. Here the line is y equal to x. But y equal to minus mod x, so minus mod x is just the graph comes downward. In the case of y equal to minus x, you say y equal to minus x if x is greater or equal to 0, because for x is greater or equal to 0, mod x turns up x, so it will become y equal to minus x. So this minus x line yields over here. And for x negative, it means for x negative, mod x turn up minus x, and minus sign is previously, so y is equal to negative of negative x, that is y equal to x. So the line y equal to x comes over here. Two more graphs, if you see over here, then that is y equal to mod x, means mod y equal to x. What is mod y equal to x? Here y changes its behavior. If y is positive, then y is to be considered as y. So y equal to x, and here the line becomes y equal to x. But when for y is negative, that it means in negative part, so that we have to say minus y equal to x. So minus y equal to x shows that y becomes minus x. So y becomes minus x here if under condition when y is negative. So this is the rules strict over on range. Although this is not the function, this is a curve. Here also minus mod y equal to x is just flip it leftwards, as here mod y equal to x, if you see y is positive, then here becomes y equal to minus x, or you say minus y equal to x. Okay. So let's see some more graphs. Y square is equal to 4ax, here that is y square is equal to 4x. This is a parabola, y square is equal to 4x. If there is even power on y, so graph is symmetric with respect to x-axis. So that is y square is equal to 4ax, you can see over here. Here if you see y square is equal to minus 4x, once again the graph flip leftwards. How these all are flipping over here? Sometimes leftward, sometimes rightward, sometimes upward, sometimes downward. If you see here, then here x square is equal to minus 4ay, that is downwards. This we will discuss later on in transformation. So come to the point, y equal to ax square. As there is an even power on x, so graph is symmetric about x-axis. You see over here, and here this depends on, if you zoom in this portion, y equal to ax square, and let me analyze over this one. So how this comes over here, you see, as the power of x increases, the graph shrinks towards y-axis. So let me explore this this part, how this is coming. So as the power of just this one is y equal to ax square. Okay, so greater is a, steeper is curve. If a is greater, the curve becomes steeper, and it's also depend on power of x. Let me explore this more on this. So I want to show over here, as like suppose we say y equal to here x square. So this is the graph over here, that is y equal to x square, and here the graph is y equal to x square. This is y. And suppose if we are interested to draw y equal to x to the power 4, then how we will go for this? So y equal to x to the power 4, if you see, the graph goes like this way. Up to 0 to 1, the graph crosses at 1, and here the steepness comes over here. This is point at x equal to 1. Here also the graph goes like this way at just -1. At the point is 1. Here graph crosses over this. This is -1. Between 0 to 1, blue curve line is downwards rather than white, and here also blue curve line is bit down, and in this way here blue curve line is more closer to y axis rather than white. So if you see more over here, but here this is y equal to ax square. As the value a greater, the graph becomes steeper. Okay, fine. Like this. One more graph, 12th part, that is y equal to 1 upon x to the power n. You see here, y equal to 1 upon x to the power n. This part. If n is odd, n is greater or equal to 1, means 1 y equal to 1 by x square, you know, y equal to 1 upon x, 1 upon x square, 1 upon x cube, like this type of graph. That's okay. So if there is a x odd power, so graph shares first and third quadrant. And you see over here, if there is even power on y, if there is even power on x-axis, if there is even power on x variable, then graph is shares first and second quadrant. Okay, now, so y equal to x to the power n, n is greater or equal to 2, you know, here for n is greater or equal to 2, the graph shares here if there is even power. So graph shares here first and second quadrant. That is a quadratic nature, x square, x to the power 4, x to the power 6 type of structure. Graph is symmetric about y axis. Fine. One more here, if you see y equal to x to the power n, here we say, here if you see that this shares first and third quadrant, as x cube graph. This is also called, you say, cubical parabola. If it is power 3, then it is called cubical parabola. Let me write down cubical parabola. Its name is cubical parabola. Okay, fine. So if it is 5 degree, then it is 5 degree polynomial. So if it is curve is 5 power 5, then graph somehow more steep rather than power 3. Like if you see, I can draw over here to make a difference between x cube and x power 5. So let's go for, this is, as you know, this is x-axis and this what I call y-axis. So if it is 1 over here, then you see y equal to x cube graph. And here, although x equal to 0 is the point, it is also called point of inflection over here. Later on we'll discuss in detail. So let's go for y equal to, although this is the graph here, you know, that is y equal to x cube. You can write over here y equal to x cube, and let's, so y equal to, we're interested to find x to the power 5. So let's say x to the power 5. This part is x to the power 5 graph. This part is goes for x to the power 5. Let me take x cube graph more clear over here, so that you can go like this way. So like this, and this part is, here you say -1. Here you see this is 1. Here this is 1, and here this is -1. So if we take somehow y equal to x to the power 7, it goes bit downwards and like this, and it goes like this way, like this. Here that is y equal to x to the power 7, you know, and white portion is, that is y equal to x to the power 5, you can say. These type of such graphs are there. Okay, I hope so it is clear. This is y-axis, this is x-axis. Fine. So let's see over here, that is cubical parabola, this type of graph. So hope so you all are getting about graph. Let me take such a single revision over here. This is y equal to x line, you know, this is here, you see. So that is the line here, y equal to x, y equal to minus x, y equal to mod x graph, y equal to minus mod x, mod y equal to x, minus mod y equal to x, right? Take one more short for revision. Y square root of 4x, these are the parabolas, okay, in sharing in each and every different quadrants and different alignation. Y equal to ax square, y equal to 1 upon x to the power n, sharing first and third quadrant as n power is odd. If n power is even, sharing first and second quadrant, you see y equal to 1 upon x to the power n. Once again, this is also called rectangular hyperbola. This is called here rectangular hyperbola. This is called rectangular hyperbola. Okay, fine. So what we say here, y equal to x to the power n, if n is integer, then it's still this called parabola, and here another that is called cubical parabola. Okay, fine. So let's go for transformation, which is the section 5 part. In transformation, first of all, we will check the shifting of graph along x-axis. So this is the transformation one. We will discuss in detail. So let's say we will take some example to understand over here that y equal to x, that let's say that is y equal to x, y equal to x minus 1, and y equal to x plus 1. Let's go and draw these three graphs and understand how the behavior they are showing over here. So let's say this is the graph y equal to x. This is the graph, you know, y equal to x. This is the graph of y equal to x line. Now this is the graph of y equal to x minus 1 line. This is the graph y equal to x minus 1 line. So the graph shift bit where, you know, this is x-axis and this is y-axis here, y equal to x minus 1. Let me say, let me mark the point here, x-axis, and here you say y-axis. Okay, fine. So let's say y equal to x minus 1. This is the graph. 1 unit comes ahead here. It's okay. And now y equal to x plus 1. How y equal to x plus 1? It goes bit ahead like this way. So if you see over here, there is a distance of 1 unit, and here also the shift of 1 unit. Here the shifting is towards leftwards, and here you see the blue line shift towards green in rightwards. So if you green one shows x minus 1, the graph means y equal to x line, that is the which is y equal to x line over here. You see, this is the line y equal to x, you can say. Okay, and this the line that what we call here y equal to x minus 1, y equal to x minus 1, and this line what we call over here, that is the red line, that is y equal to x plus 1, y equal to x plus 1. So how x plus 1 comes 1 leftwards and y equal to x minus 1 comes rightwards as due to shifting. So in the same analogy, if we explore the same concept, if we impose the same concept in the graph, then what we conclude that instead of not only x plus 1, instead this one instead of this line, if we take this type of term f of x minus 1 and f of x, so fx, then f of x minus 1, then f of x plus 1. If we go for this for any type of function, so fx is as like this one, this part will become blue over here, so this part blue, then f of x plus 1 will come for a red, f of x plus 1 as like y equal to x plus 1, and f of x minus 1 go for this one green part, which is rightwards. Later on we'll discuss more detail. Let's come to some illustration. Before this, that is so not only for general 1 unit, here if we see f of x plus a unit, mind this point, here transformation 1, y equal to fx, y equal to f of x plus a. In f of x plus a, what we have to do, let's say here this part of the graph is, this is graph, what do you call, fx. If you see over here, this graph is y equal to fx. This part of the graph is y equal to fx. Let me overline this. This part of the graph is fx. Okay, this part. And here afterwards, this part ahead, let me draw this one as in the previous order. We have drawn this as blue color. So let me draw with this blue color. This was fx, this part of y equal to fx. Okay, fine. This is y equal to fx, So y equal to fx, we have drawn some graph which is passing through origin. So for f of x plus a, what we have to do? F of x plus a as in the red color, as we are y equal to x plus 1 instead of this x plus a. We were shifting leftwards, so y equal to f of x plus a, if you see, then the graph is this part. This part is f of x plus a, This is f of x plus a. You can recall over here. This is as f of x plus a. So let me write down y equal to, this is f of x plus a. Okay, x plus a. F of x plus a. And here in the green part, if you see our green part over here, that it means f of x minus a unit, this one rightwards, that shifted rightwards here as a unit, you see, goes rightwards, a unit here rightwards, and a red part, this is goes leftwards. Okay, so what we see over here, whenever we are adding some positive number, a is should be positive. Here, mind this point, that is the point to be noted. Here a is considered as positive number. If you take a as a negative number, then just all things will be reverted. It's okay, fine. So let's see over, this is the first transformation. Let's take some illustration over here. Fine. So let's see, we will take one question to draw the graph here as 4y equal to 2 to the power x. So let's take some as a question over here. So what we see here, 4y equal to 2 to the power x. Let me try here. 4y here, let's see. 4y equal to 2 to the power x. Okay. So if we solve for y, then what we can write here? Y will become 2 की power x upon 4, and later on we say 2 की power x upon 2 की power 2, and hence we can say 2 की power x minus 2 we can recall. So what we have to do, we are planning for this, that it is y equal to, that is 2 की power x minus 2. So we have to draw the graph of y equal to 2 to power x minus 2. So what we will plan over here, to just solve this for y equal to 2 to power x, then what we call here, as we got that y equal to 2 to the power x minus 2. So we will plan step 1, we have to draw first of all y equal to 2 to the power x graph. Let's say y equal to 2 to the power x graph. Let me draw first. Here this is x axis, and this what I call y axis, and this is the graph of y equal to 2 की power x. This is the graph here, 0, 1. This is 0, 1 part, and the graph is here y equal to 2 की power x, right? Now we are interested to find 2 to the power x minus 2. It means instead of x, what we are getting here, for x we have to replace with, that is x minus 2. We have to replace x with x minus 2. So here if you see in this, if we can recall any function f as go for f of x minus 2. If we come for function, so fx come for fx minus 2. So we have to concentrate on this analogy. We are using this concept. So transformation 1, that is minus 2 unit. So if you see minus 2 units, so graph will shift ahead or backward. So of course f of x minus a, as we have seen that graph shift rightwards. So this graph shift bit rightwards. Bit rightwards means 2 unit ahead. So we will plan our here self to just make it 2 unit rightwards. So 1 and here 2. Let's see, 1 unit here and 2 unit over here. So whatever the point over here, that is 0, 1 is coming over here. So this point comes over here, and the graph will goes like this way. It's okay. And still when you put here 0, then x 0, when you put 0 over here in this blue part, so that will become 2 to power minus 2, that is 1 by 4. So it graph crosses on y axis at 1 by 4 unit. Later on we will discuss detail. Anyhow, the graph comes like this way, okay, and here this part, if you see this part, okay. So let me go, and you have to sincerely consider this part, blue portion. So this is going here 2 unit, let rightwards. Let me consider 2 unit rightwards. So this is 2 to the power x minus 2. Let's see more. Now one more question is there. Here if you see 2 to the power x is here, and we have to consider that 2 to the power x minus 2. So this is the graph of y equal to 2 to the power x minus 2. In another one question, that is y equal to, you see here, that is y equal to 4 into 2 to the power x. Then in this situation, what we consider over here, that y equal to, what we call y equal to as 4 into 2 to the power x. So we have to consider as 2 to the power x, right? So for 4 you can say 2 to the power 2 and 2 to the power x, you say, as here you see. Let me write down once more. Y equal to 4 into 2 to the power x. So for 4 we can write 2 to the power 2, and for 2 to the power x, that is 2 to the power x. This can be written as 2 to the power x plus 2, and this is y. So for here, what we have to go for, we have to as consider f of x plus 2 transformation. So fx to be considered as 2 की power x. If you consider fx as here, that is 2 की power x, then for f of x plus 2, what we have to go for? 2 की power x plus 2. So let's say we are interested to draw the graph of f of this part. So let's say this is 2 to power x graph. This is y equal to 2 की power x graph. And this is y-axis. This is what I call x-axis. And now we are interested to find 2 to the power x plus 2. So graph goes bit towards leftwards. Graph goes bit towards leftwards. And here when you put x equal to 2, then the graph goes like this way. X equal to 0, then it will becomes 2 to power 2. Here the result was, that is 0 comma 1. And later on when we go for 2 की power x plus 2, as this part 2 power x plus 2, so graph will go 2 units leftwards, 2 unit. So it comes like this way, and here this one is y, as this will become 0 comma 2. So let this be 2 unit, and this what we call over here as y axis. Let me note on once more, that is y axis here, and this is 0 comma 2 part, 0 comma 2. You see this part is 0 comma 2 here, and the graph goes like this way. Let me overline over here, let me highlight like this way. This part is y equal to this part, y equal to, that is you see y equal to 2 की power x plus 2. Okay, fine. So and here that is y equal to 2 to the power x. This one is y equal to 2 की power x, and let me highlight this part also. So this is y equal to 2 to the power x, and this is y equal to 2 to the power x plus 2. This part is y equal to 2 to the power x plus 2. Okay, so come to the point here. Here if you see y equal to 2 to the power x plus 2, graph goes bit towards here. You see over here. Let me use if you want. This part is y equal to 2 की power x plus 2. As the graph is here y equal to 2 to the power x part, let me wrote over here. This part is y equal to 2 to the power x. This part, if you see, this is the graph of y equal to 2 to the power x, right? And here for this graph, if you see over here, this is the graph here, y equal to 2 to the power x plus 2. This portion is 2 to the power x plus 2. It goes 2 unit leftwards. It's okay, fine. So let's see some more illustration on this. Okay. And your transformation 2. Second transformation is as in the first transformation, the function is shifting toward along with x-axis as the changes are in the domain. In the second transformation, we'll discuss as the changes are in the range, means along y-axis. So despite of first transformation, as here if we say y plus a equal to fx, so we are changing over in the function y minus a fx and y plus a fx as like x minus a and x plus a, f of x minus a and f of x plus a, respective order. But here if you see, we have to make y equal to a plus fx, that it means y minus a equal to fx. So y plus a equal to fx, if you say, then fx will go downward over here as y plus a, and y minus a, that is the same. That's okay. So here if you see y plus a, fx means y equal to fx minus a, y equal to fx a. Here when you transform this a, then it will become y equal to fx, and here that is minus a, not f of x minus a, it is fx minus a. So it comes downward. This part is fx minus a graph. And here if you transpose this a over here, then it will become y equal to a plus fx. Y equal to a plus fx. Alright. So in that situation, the fx goes this part. This part is y equal to a plus fx. So it goes above graph, and here a unit above this part. This part is here y equal to y minus a fx, and this part, that what we call here y equal to fx minus a. You can say y plus a equal to fx. This part is the graph here. Okay, fine. So let's take some illustration on this to understand. The illustrating concept is, we are interested to draw the graph of y equal to cos square x. So how we will plan over here? If you see y equal to cos square x, so y equal to, let's say the graph is here. So let's explore this. Y equal to, that is what we call here y equal to cos square x. As for cos square x, one can say 1 plus cos 2x. This is well known formula 2. So what we recall over here, y equal to 1 by 2 plus cos 2x upon 2. So what is our planning here? In this planning, what we have to do, we have to draw the graph of half cos 2x, and then we have to shift this graph half unit. So where the half unit shifts, as we have already discussed, y equal to a plus fx means fx goes above x-axis a unit. So here half unit above x-axis. So you see here, so how we'll draw the graph of cos 2x by 2. So let's say, as cos 2x by 2, if you see cos x period is 2 pi and cos 2x period is, you say, that is its period, you say period is, I can say, that is 2 pi upon 2. Coefficient of 2 you have to divide, coefficient of x. So that is 2 and 2 related, and that is period is pi. So within this pi, it completes one complete cycle. Within this, it completes one cycle within period pi. As in 2 pi, cos x completes its cycle. So within this pi, it completes one cycle. So this part is, and its amplitude will become 1 by 2, as this part is amplitude, you say. This part is here, that is 2, that what we call amplitude. So 1 by 2 will be the amplitude over here. Anyhow, so let's draw first of all cos x graph. So how to draw the cos x? Let me choose this red color. So to draw the cos 2x by 2, so we will draw cos 2x upon 2 graph. So let's say graph goes like this way, and here, okay. So this part is cos 2x part entire. This is x-axis, and graph goes like this way, and so on. But this is 0, and this what you call here, that is pi. Here this point is, as it should be 2 pi, but the period completes over here, so it is pi. And this is this was pi, so this becomes pi by 2 part. Pi by 2 part here, because at pi by 2 it becomes pi, and it retains minus 1. So this is minus 1 by 2 here, and this one is 1 by 2. So cos goes like this way, cos 2x by 2. But for half cos 2x, what we have to do? For half cos 2x, we have to lift this graph above 1 unit. Or in other words, you can say also that better just you can shift this x-axis, shift this part of x-axis here, x-axis, this x-axis here, 1/2 unit downwards. So better just we will go like this way, x-axis over here. With respect to this new x-axis here, and this as y-axis, the graph is, and the point will become here x equal to 0. Here, that is the value will become, that is 1. You see over here, cos 0 degree is 1. So half plus half, that is 1. So 0, 1. 0 comma 1. This part is the graph. So let me draw this with the help of blue line. This part is the y equal to 1 by 2 cos 2x, 1 by 2 plus cos 2x, and this is x-axis, and this what we call y-axis over here, and this is x-axis. So finally we will get the graph like this way. So let's see once again in the illustration. So you see y equal to 1 by 2 cos x part, 1 by 2 cos this part, y equal to half cos x, that we say half cos x by 2. Let me bold over here. This part is cos x by 2, cos 2x by 2. You see over here y equal to cos 2x by 2, and here it completes one complete cycle, as if you see this is pi and this portion is pi. Okay, from 0 to pi, here this part is y equal to cos 2x by 2. This is the graph of y equal to cos 2x by 2. Now this same portion, instead of doing over here like this, we can shift this as x-axis as here. We can shift this as x-axis over here. Here, this is as x-axis. So the graph will become like this. Okay, so finally the graph will become like this way. If you see here, this is the y equal to half cos, y equal to half cos, half plus cos 2x by 2. This is the graph, you know, this is called, you can see over here. Okay, this is the portion what we call y equal to cos square x finally. So this will becomes as, if you transpose this half over here, then it will become y equal to half plus 1 by 2 cos 2x, and here it becomes y equal to cos square x, you see. So this is the graph of y equal to cos square x, and cos square x graph will comes here, and now this is x-axis, you know, and here there is y-axis, you see over here, and the graph is like this way. This is the graph of y equal to cos square x. Okay, fine. So it's spanned over here 0 comma 1. Okay, fine. So take one more concept, one more illustration over here. Plot the graph of y equal to e power x minus 1. Y equal to e power, we are interested to draw the graph of y equal to e power x minus 1, a part, and how we will manage over here. So let me discuss in detail how we will shift y equal to, we are interested to draw the graph of y equal to e power x. Let me see once again, e power x minus 1. Okay, fine. So y equal to e power x minus 1, right? So first of all, what we have to do, we have to shifting along y-axis, as you can also say y plus 1 equal to e power x. So what we have to do, we have to shift downwards if we are not shifting axis, or better just e power x minus 1 means we have to shift the curve downwards. We have to shift the curve downward, or you can say while shifting the curve downward, if you make the curve static with respect to that, x-axis can shift above like this. So let me do like this way. Here, let this be x-axis, and this what you call y-axis. This is y-axis, and let me draw y equal to, first of all, that is y equal to e to power x. So how to draw this e power x? This is the curve of e power x as it passes through 0 comma 1. Now let's say we are interested to find then after y equal to e power x minus 1, how this comes. So curve should be go downwards, or better just you can shift this axis above 1 unit. So I am trying over here to shift x-axis above 1 unit, so the curve will comes automatically downward. So let's see. Achha, one more thing is there. We have to shift entire this one curve 1 unit downwards. So while shifting the x-axis above along with y-axis, the new x-axis becomes like this way. Let's say this part and this part, and here, so y-axis. So now this white curve automatically it becomes, and this is a new axis, and this becomes y equal to e power x minus 1 graph. See how we can cross check. Put x equal to 0 over here. The result will be any number at power 0 is equal to 1, and 1 minus 1 0. So y becomes 0. So here the new point will become 0 comma 0. So this 0 comma 1 point becomes 0 comma 0 for this curve. This is the graph of y equal to e power x minus 1. Okay, fine. This is another way you can shift the graph downward also, like this. Here if you see, this is the graph y equal to e power x. You can see over here, y equal to e power x. This is the graph, and here we are shifting graph downward. We have to shift the graph downward 1 unit, not more. This is the graph here. Here this part of the graph. That's okay. Anyway, so this is the graph of y equal to what we call here, that is e power x minus 1, or you can say y plus 1 is equal to e power x also over here, as y plus 1 equal to e to power x. Fine. Okay, so this is the graph. One more result is there, one more question we have to follow. Y equal to log x base e minus 1. How to graph this? Let's see. Log x to the base e means ln x minus 1. You see, y equal to ln x minus 1. So let's see over here. Y equal to, we are interested here to draw like this way. Y equal to ln x minus 1. Minus 1, you can say sometimes it can be also written as for one can write ln e, and they can say you have to draw the graph of ln of x by e. It's okay. That is the same thing. Same thing you have to say. So ln x minus 1. So you have to shift the graph downwards over here 1 unit. So how to select here? Or y plus 1 you can say. You can say also y plus 1 is equal to ln x. So you can, instead of shifting the graph downwards, better just you can shift the x-axis above. So I will shift our x-axis here to just demonstrate it. So let's say this is the graph of y equal to ln x. This is x-axis, and this is what I call y-axis. This is the graph of y equal to ln x, and here this is 1 comma 0, as this is the graph. And now what we have to say, y plus 1 equal to ln x, y plus 1. So here what we have to do, we have to shift our x-axis at 1 unit. We are approaching here 1 unit, and so the graph automatically shift downwards. So if you lift this x-axis 1 unit over here, 1 unit over here, so it goes 1. So let's say x equal to, we say e, so ln e, that it means it become 0. So this part, you know, this is x-axis and this is y-axis. So we have to manage, although subject to the scaling is not yet clear. So this part is e, so that x equal to, at x equal to e, what we say here, this part is e comma 0, e comma 0 we will get. How? Let's see. As if you put x equal to e over here, so ln e will becomes 1, 1 minus 1 0, and here this point is e comma 0. So now this is x-axis here, and this what you call y-axis. This is y-axis, and hence this, the graph will become this red, this same graph, and here this is x-axis, and this what is y-axis. So the new red color is x-axis, and new y-axis with respect to this same graph will become ln of x minus 1. This graph will become y equal to, that is ln x minus 1. Okay, fine. So let's see over here how to draw the ln of x minus 1 with the shifting graph here with respect to axis, not the shifting with respect to, not shifting the axis, let's say over here. So this is the graph of here, that was previously y equal to shifting of e power x 1 unit downward. Here what we say, ln x minus 1 . So here this is the shifting of ln x minus 1 towards right, and here towards left, that is y plus 1 equal to ln x. Okay, fine. So one more transformation we will discuss later on. That is y equal to cosec of minus, let's see over here. So there are, okay, transformation 3. What is transformation 3? Transformation 3 is y equal to fx, and now we have to transform y equal to f of minus x. Y equal to f of minus x. How to see? To plot f of minus x, draw y equal to fx. Okay, then take the mirror image of y equal to fx in the y-axis. Take the mirror image in the y-axis. This part we have to do over here. So let's say we have to draw the graph of y equal to e to the power minus x. So we have to take the mirror image with respect to y-axis, as it is said here. So y equal to e to the power minus x, and we have to later on we have to practice the graph of cosec x, cosec of minus x with respect to in the interval minus pi by 2 to plus pi by 2. So let's see over here. Okay, so y equal to this one, y equal to e to the power minus x. Y equal to e to the power minus x is here, as it is ascending function, increasing function you can say, and e to the power minus x, that will become decreasing. And y equal to cosec of minus x, that we say, if you see y equal to cosec x, as x lies between minus pi by 2 to plus pi by 2, it's sharing first and third quadrant. So as while taking the graph image with respect to x-axis, if you see over here, taking the image with respect to y-axis, you see, then the graph, this part, first part of the function, which is in first quadrant, it comes in second quadrant. This part comes in second quadrant over here as the image, and if you see over here, this part which was in third quadrant, now it comes in the fourth quadrant. Now it comes in fourth quadrant, because both sides will have to take a mirror image. So this as cosec of x shares first and third quadrant, you know. So here cosec of minus x shares second and fourth quadrant. So this is the transformation 3.